some red dots there.
Yeah.
Okay.
Sounds good. Wait.
Yep.
Should we go buy some drinks or something?
Yeah. Where
Just wait for one more minute to start right at 4:30. Thanks everyone for coming. I guess no food today. Yeah. Sorry about this. I just noticed the title is slightly different from what we advertised.
I changed title, but the same stuff.
Yeah,
Yeah.
okay, okay. Great. So I think I'll just go ahead and start. So thanks everyone for joining us for this NLP large language model interest school. Today we are very happy to have Dr. Tong Wang to give us a talk. So she's the assistant professor from the Department of Marketing, School of Management. I'll let her to introduce more about her background, but the title is right here. I'm not gonna read it, just something about large language models. Thanks, Tom.
That's all the talks in this series about.
Yes, exactly.
Okay, a little bit about myself. I'm an assistant professor from the Yale School of Management, and but my training was actually in computer science. I got my degree from computer science from MIT, and then I focus on developing interpretable machine learning models to solving business problems. And today, this is a ongoing work with my colleagues from School of Management. And in this project, we're developing a new method to try to improve a lesser LLM through the help of a better LLM, and solving a particular problem for which we call goal-oriented dialogues. Although this is not related to biomedical topics, but I hope that the methodology is generalizable enough such that you could find it relevant to your own projects. All right, let's get started. So, like LLM is the hottest thing right now. It can solve many types of problems. And that's why different companies and research institutes, they have developed different types of LLM. So there are a lot of a lot of options for us as users or researchers. So if we look at their options, here I'm just showing a very small subset of all the other options. They span the entire spectrum of different cost and different sizes, different performance. Now, if we compare them, and specifically we care about their price versus quality, you will see that this is upward trend, right? Generally, you're paying for something. So if the more you pay, you're getting higher quality. But imagine if I'm a company and I want to use it for some commercial use. And then, of course, I'll care about both. I want high quality LLM, but I'm not reluctant to pay that much, right? Some LLMs are more than 10 times or 20 times more expensive than their smaller counterparts. So we're particularly interested in that for this this cheaper LLM or some of the free version. This open source Llama is free, right? Is it possible that we can improve their performance utilizing maybe the better LLM to help us improve it? So we solve this problem in a particular context. Here, the application is that suppose we're trying to use LLM to act as a chatbot or agent for customer service. This is actually a very important problem in the business world because the human agents are very costly. A call center could spend millions of dollars each year to hire like hundreds of agents to interact with customers. And also they're not scalable, right? If there's peak time, you could have double or triple the traffic arriving at the call center and the customers have to wait. So that's why recently there's a growing trend of using AI, especially LLM, to automate this service. And there's forecast of rate reach 10%, up from only less than 2% in 2022 in 4 years. So this type of problem, particularly using an LLM to interact with the customer, is called generating goal-oriented dialogue. So I want to emphasize that this is different from the one-step tasks such as sentiment analysis or text summarization, where you have the input and then you generate something, okay? It is different in the sense that this is a multi-turn generation. So you need to actively interact with the customer. And every time your response is determined by the customer response, whose response is determined by previous conversation, right? So it's a trajectory of interactions. All right, so here's an example. So, and the goal of this generating this complicated interaction is to serve some purpose. In the context of customer service, the agents serve them in order to achieve high customer satisfaction. Now you can think of other applications where, so for example, we're trying to persuade someone to make a donation, right? And then your goal is successful donation. So there's different, but they're all called goal-oriented dialogues. Okay, so in this context, how do we use a better LLM to teach a lesser LLM? Now here we decide to use prompt generation. And we want to generate a prompt that includes strategies created by the teacher. Teacher means a better LLM, such as GPT-4. And then we want to use the strategies from the teacher, which instruct the student how to respond. We choose prompt generation because it does not need to update the student LLM parameters. So you don't need to involve the heavy fine tuning and the training. That costs a lot, right? Okay. So why not fine tuning, right? So for people who use LLM a lot, well, fine tuning would be like the first option you would resort to if you want to have good performance, especially you wanted to adapt to some domain. So a possible solution would be you let the teacher generate the training examples and then use that as a benchmark answers and then fine tune the student. Well, the problem with that is it will need to update the billions or even trillions of the parameters of the student. And it's not as flexible. Suppose you want to generate a model for one task and then slightly a different another task. For the best performance, you need to retrain the model again, like refine tune the model again and save a copy. A copy means you have to save the set of billions or trillions of parameters. That's costly. And also recent research has shown that actually when the model size is large enough, the prompt tuning, if you can optimize it in some way, can guarantee you very good performance. Now, this research is published in 2021. So you will see that model tuning, which is the orange, is still above prompt tuning, but you can forecast the trajectory, right? We can forecast that as the model size grows larger and larger, right? Forecast this could be the trend, right? Because as the model becomes larger and more intelligent, it is able to do better in following the instructions. And luckily, all the models that we care about, they are like lying in this range. So we can reasonably expect that prompt tuning would perform better, okay? All right, so let's think about the existing prompt tuning methods. When people talk about prompt tuning, they're specifically meant the soft prompt tuning, which means the prompts, instructions, they're not really at the text level. They are represented by a set of parameters that you can optimize, you can train by designing some objective function, right? So the benefit of that is that you will keep the model intact, but you have to train the set of parameters representing the prompt. But the prompt you get will be unintelligible. You won't understand what you are getting. And also it's incompatible with other LLMs because they're represented in their own embedding space. So if you want to use it for another model, it will have a different meanings in another different embedding space. So it's not transferable. And also for for prompt tuning, you need access of the model. Because you have to concatenate the prompt with the embedding of the input. So it does not work for LLMs with only API access, like GPT-3. You cannot do prompt tuning. And also, usually for the existing work on soft prompt tuning, it's for fixed prompt for a task such as sentiment analysis or text summarization. So you learn one set of parameter for the entire task. Okay. And why it does not apply here? First of all, we want text prompt such that we can understand what strategies, what instructions the teacher provided for the student, such that we understand the reasoning and basically safeguard whether there's something wrong, whether you're providing the wrong instruction for real world deployment. And also we wanted you to only permit API access such that this method is applicable through different types of LLMs, not just limited by certain models. And our problem is also fundamentally different. It's multi-turn dialogues. Okay. So we want to be able to generate scenario adaptive prompts such that for different scenarios, which we'll define later, you can think of a scenario as a conversational state. And then we want to be able to generate a prompt that adapts to it, not just like a fixed prompt that solves everything. So in summary, this is our desired property of our method. We only need the API access, which applies to both the model we want to improve, which we call the student, and also the model we want to utilize to learn from it, which we call the teacher. For both LLM, we only need API, which means this method applies to any LLM models. And we've generated prompt at the text level such that it is interpretable and transferable to across different models or across different contexts. And we want our prompt to be adaptive to different scenarios. And finally, of course, we want this whole process to be automated instead of manually constructing. Okay, let's talk about the method. So first of all, let's define the environment we are designing this. So here we suppose we're working in, we put ourselves in the airline industry, and we assume here there's a customer calling to cancel a restricted ticket. Restricted ticket means the ticket cannot be modified, cannot be canceled. So basically he's asking he's basically making unreasonable request. So we designed it such that, the solution will be a little bit difficult. If he's just making a reasonable request, then the agent will just say, yes, I'll help you, right? So making the problem difficult. And then to simulate different customer, we basically vary their personality, their emotion, and adding the description to control whether they are being demanding, to giving the agent some trouble. And then we want to design an LLM agent such that they can handle the customer, right, in this context. Now here we want to focus on the communication style and the communication skills and strategy they use, which means we have to control the solution, right? Otherwise, one agent says, okay, I'll do whatever you ask. The other agent says no, right? Then the customer will always be satisfied with the easier agent. But we want to prevent that. We just say everybody has to adhere to some company policy. You cannot just say agree whatever the customer asks you to. And given this is fixed, now the problem is how do you create how do we improve the communication skills and the strategies of the student LLM? Okay, so this is the idea. We want to create what we call a library. Now, this library consists of the pairs of scenarios and the corresponding prompts, and the prompt including strategy from the teacher for the student. We want to do that such that when we deploy the student, whenever there's a new scenario coming in, the student will find the most relevant scenario and then use the corresponding prompt. Okay, so this is our goal. This is our goal. And the problem is how to do it. So here, let's start with how do we create the best prompt. Suppose there's a scenario here. A scenario is just a sub-conversation. So this is what the agent has been talking to the customer to generate the conversation so far. All right, and then the next thing is the agent needs to reply. So how do you reply? This is called a scenario. Now, given this scenario, we want the teacher to teach the student how to respond. So how do we do that? So first of all, the teacher looking at the scenario will provide a textbook response, right? This is like the desired response. And then the student using some baseline prompt. The baseline prompt just contains nothing, just says, okay, now you role play as an agent, that's it. But do not give you any instructions. Now with this baseline prompt, and the student will try to come up with their own response. At this step, that the agent is not aware of what the teacher says. He only looks at this and this prompt. Okay, now you see there are two types of responses. And we already know that the teacher is better. So we now want to use this to improve the student, right? To do that, we use the teacher also as a grader. Okay, so he compares the two responses and come up with the suggestions to the student in order for the student to behave just like a teacher. Now, to do that, we will say something in the prompt like saying that, okay, you need to analyze to the two responses and create effective suggestions in order for the student to behave like this one. This is what we say in the prompt, such that he is able to create the suggestion presented in the do list and don't list, right? These are the things you need to follow. These are the things you need to avoid. Now, with these suggestions, it will be incorporated into the prompt, and it will get an updated prompt. And with this updated prompt, now the student looking at the new prompt, and again, the same input will create a new response. This is a new response. Now, again, this teacher is doing his job again, comparing them and provide suggestions. Okay, so there's a new suggestion.
Can I ask a question?
Yeah.
Where is the constraint you said have to follow the company policy? Is it in the prompt?
Yes, in the prompt.
Oh,
So
okay.
it's in the prompt saying this is some company policy
Oh, okay.
solution. Yeah.
Yeah, thanks.
Okay. And then you can imagine this process continues, right? Continues until the teacher determines there's no suggestion to give, or he determines their response is similar enough, then it will terminate. Okay, and then the output of this step is just a pair. The pair consists of a scenario and a corresponding prompt, right? You could think of these as a strategy, like how you should respond, how you should react in these circumstances. All right, so this just one pair of many pairs that could exist in library, right? So our goal is that we want to create many heterogeneous, different types of scenarios covering a lot of different situations, such that the student know exactly how to respond. Okay. So let's talk about how do we generate the scenario. Now, in order to generate scenario, what we could do is that we could let the teacher to interact with the customer, okay? And then generate conversations like this, all right? And if we vary some of the characteristics of the customer, right? This customer is actually generated by the GPT-4. So if we vary the description of the customers in terms of, we can say, you have this different types of personality, different emotion, different difficulty level, and we'll be able to simulate a rich set of different conversations, right? And then from that, we extract scenarios. Each scenario has to start from the beginning of the conversation and end with a customer, such that the agent can reply. So get this set of scenario. Okay, so this is a very seems like a good idea, but is it sufficient? Not really, but so I will distract a little bit by showing you one example we found from the evaluation to motivate the rest of the design. Okay, so let me show you. This is the conversation between a customer GPT. Customer GPT is GPT-4 and the agent Llama 2 7B. This is like weaker LLM. And then this is the interaction between the customer and the agent. This agent is GPT-4, so it's better agent. So what I highlighted in red is what I believe inappropriate or what could piss off a customer. So for example, at the very beginning, Llama 2 said, "Oh, I apologize," but he basically is trying to be defensive, right? If you see GPT-4, he's saying, "Oh, I'm sorry to hear that. Let me help you. Let me see if I can help assist you with anything." He's first asked for information, not showing rejective moves. And then he keeps being defensive, saying, "Unfortunately, there are no exceptions." Especially this sentence is interesting. He said, "Our policy is designed to protect both our passengers and ourselves." Right, what does that sound to you? Self-serving and defensive, right? But well, here he's basically expressing the same idea, but without using the exact the sentences. Okay, anyway, so in the human evaluation, we presented these two blind tests without telling the human evaluator which one is which agent, just showing him two conversations and ask him to evaluate which agent is better. And this is what we get. One of the human evaluator said agent 2, which is this guy, appears to be more concise and clear, though it does seem like agent 1 was dealing with a more difficult customer. Okay, he thinks this customer is more difficult. And yes, if you see the entire conversation towards the end, the customer indeed becomes more difficult and demanding. But this is very interesting because it is exactly the same customer. When we generate the two conversations, we use exactly the same prompt and same LLM. So how come these customers appear more difficult with this agent? Why is that? And here is why. Okay, so in the training data, right? So if we let a very good agent to deal with the customer, the agent is giving you excellent performance, is making the customer very happy. So the customer is in the happier mood, he's being polite, he's being cooperative, and everybody's happy, right? Suppose now you have a slightly worse agent, okay? Maybe at the choices of sentences or choices of words are slightly different. At the very beginning, he says something slightly pissed off. So the customer becomes a little bit unhappy. But then, things can go wrong at every step. Every step you said something wrong, and the customer becomes more and more unhappy. That will lead their state to become happy or come to being pissed off. And then eventually, you're getting a seemingly more demanding customer, okay? And also see that if the model is trained here, the model has only seen scenarios and states generated in the training data, which is far away from what he could end up with, right? Now, eventually, the student will end up in the space where these scenarios he has never seen during training. Then you could give an even more worse performance because he has never been trained on this, right? So this is a very typical problem in imitation learning. It's called distribution shift, which means every deviation at the state, at the earlier trajectory, could lead you to, give you very bad outcome. There's like a compounding error because every time you make little bit mistakes. All right.
So for the training data, is it real people behind doing the?
No, there's no real people because we need to do like online. So every customer is a customer is a GPT-4.
Oh,
Yeah.
customer is also a GPT-4.
GPT-4, yes. Yeah. Okay, so the solution of this is designed like this. Now, instead of only letting the teacher to interact with the environment, which is the customer, we also allow the student with certain probability, because this is like a switch, right? So at the very beginning, we always let the teacher interact. But then as the iteration goes, we increasingly involve student in the conversation generation. And then such that the scenario will span the entire spectrum of different scenarios that a student could encounter during deployment. All right, so here is the idea. So we have this, we use teacher and the student together to generate scenarios. And then in strategy teaching, for each scenario, we will learn the optimal prompt. And these will be added to the library, right? Then as the library grows, the student will become more and more competent. And then the better and better student will also participate in the scenario generation. So gradually they will improve. Okay, so does the idea work? So of course we have to test it. All right, so in order to evaluate it, we will use both the GPT evaluation, where we use GPT as we ask GPT to pretend you're a customer. Now you look at the conversation and then choose. And then we also involve human evaluation. And then we also test the transferability. Okay. Now let's start with the GPT-4 evaluation. Now here we ask GPT-4 to act as a customer and then show him the conversation and say, now you pretend you're the customer. Now rate the conversation in terms of satisfaction. 1 means very dissatisfied, and 5 means very satisfied. Okay. So this blue is before, and we tested on 4 different student models. Right? You will see that there is an improvement in all of them. Right? This color is the after. So there's a consistent improvement. And here we show the average rating. In customer satisfaction, specifically, we often care more about the percentage of 5s, because if you're under 5, it means there's something wrong. Something made you unhappy, and that could cost you a customer, right? So another important metric is also the percentage of percentage of fives. Okay, so the improvement is more obvious, right? This is the original blue and this is cyan. So you might think that it's still low, right? But it's not low because GPT-4 is here. This is GPT-4's performance. So you see that the gap is closer, right? Even the previous average, you'll see that this gap is smaller. So it's approximating the GPT-4. Okay, and then we do human evaluation. We did a blind test using basically following exactly what I have described. We show two conversations interacting with the same customer, but with two agents. And the human does not know which one generated which. Okay, so this is before. Before we showed them 30, basically we conducted like 32 conversations, each evaluated by different people. And before this, almost everybody chooses GPT-4 over Llama 2. Okay, and GPT-3 is slightly better, 7 out of 32, but still it's dominating. And then we're trying to improve it. If we're getting close to 50%, which means we're being performing very close to GPT-4, right? So this is what we get. We're not getting 50% there, but very close, right? This one is 41%, this one 34%. So there's a very significant increase. All right. Okay, so another thing we want to test is why there's improvement. Now, in order for the algorithm like this to be successful, there are two things that are very important. First of all, can the teacher provide useful feedback? Can the user teach the student useful strategy, right? And then the second question is, does the student learn? Does the student follow the strategy, right? For the first question, here we show an example. This is a customer said something, said, okay, I want to cancel it. Can you assist me? Before we applying this method, he said, this is what he says. This is Llama 2, 7B, right? Very long, right? And this is GPT-4's response, very concise, but offering to help, okay? And then the teacher said, looking at this, the teacher provides some suggestion. The teacher said, okay, you should provide direct assistance instead of begin a response with a direct offer to assist, focusing on what you can do immediately. And another thing he said is that request necessary information upfront, right? Based on his own response, he said this is what you should do. And also there are things that he recommends not to do. For example, avoid disclosing negative information. Well, he said too much here. When customer said, can you help me? He already says, oh, I understand this might not be what you want. Oh, I cannot do that. This is what the policy, right? If you're the customer, you will feel bad about it. And he also suggested don't overload with policy details initially. Right? This is a very, very effective and a very clear suggestion. Okay, so the teacher does provide useful strategy, right? With our human eyes, it makes sense. But does the student listen? And this is what happens after we provide this to in the prompt. And effectively, the student immediately changes his response. And he says, oh, I'd be happy to help you. And this one is more similar to follow the GPT-4 strategy. Okay. Right, because of these iterations, and that's why we see the performance improvement, and that the GPT-3 and the other student models perform more similarly to GPT-4. Okay, and then the other interesting we want to test is transferability. Now, this is different from a soft tuning where you have the numbers that is not transferable. Here we learn text level prompt, it's strategy. Strategies are transferable, they are generalizable, right? So we want to do two tests. The first one is to test the transferability across student models, which means what if we just train one student model, let's say the cheapest LLM, which is Llama 2 7B, it's free. And then we use the generated prompts for other students. Maybe it's GPT-3, which is more expensive, right? This is the first transferability test. And the second one, we want to test whether it is transferable across contexts. Now, remember, when we train our model, we train in a specific problem where we assume the customer is calling to cancel a restricted ticket. But for customer service, you're dealing with all kinds of problems, right? This is just too limited. So what if we train it on one and then test on the other, even though that the student model has never seen it? But there has to be some similarity in it. There has to be some similarity in how you should respond to customers. And then that's our second thing. Okay, let's see the first one, transferability across student models. So we use the prompt learned for Llama 270 on other LLMs, okay? And this orange is the using Llama 2 prompt. So you see that it performs less than using their own prompt. So it's lower than this bar, but still higher than the baseline, right? And this is the average rating. This is percentage of fives. Okay, so basically they're in between. So which means they're not as good as using your own prompt, of course, because that your prompt is optimized for yourself. However, it does offer value, right? You still can learn something here. And if we want to visualize it, so suppose this is the space of scenarios, right? Before training, this is the teacher is dealing with all this kind of different scenarios. When we train the model, when we run this algorithm, what we are actually doing is that we're trying to find scenarios that the student could encounter during deployment. So we are generating these different scenarios to cover the space such that the student, when he's deployed, he's able to locate the relevant scenarios and use their prompts. And when there's another student, say this student is not trained, right? He will still be able to use these prompts, even though they're slightly far away from it. So that's why, because it's far away, so the prompt is not good enough, but still these prompts are generalizable. Okay, so as long as they're in the same space, it's transferable. Okay, another transferability test is across context. Now in this one, we simulate another problem. We simulate that the customers, they have lost their luggage somehow. And then they're calling to complain, and then they seek a compensation of 10,000. That's a lot, right? We're not simulating asking for 100 or 200 because the agent could easily say yes. When you make it 10,000, it's hard to say yes. We're basically forcing the agent you have to say no, you have to reject him. But how do you reject him in a way that you don't offend him? You still try to make him feel not irritated, still try to make him satisfied. Okay, so that way we focus on the communication skill and the strategies in responding. All right, so this is the result. So you will see that it still improves, okay, but not that much, but it still works, okay, even though, when for this cyan color, these agents have never seen this before, but some of the strategies are transferable. For example, how you apologize. Do you apologize repeatedly, or when do you apologize? What is the timing of apologizing? And how do you communicate it with the customer? So these strategies, they're transferable across different contexts. All right, okay, so this concludes the talk. So we proposed a method that can distill teachers' knowledge into a library of prompts. And each prompt will instruct the student how to respond in different scenarios. And for this method, we only need API access for both the student and the teacher. So basically, you can apply it for any pairs of LLM. Any LLM models can use this method. And we have seen the performance improvement achieved across by the various LLMs across different contexts. And because it's text prompt, it is interpretable, so you understand what the strategies are. And it's also transferable across models and across contexts.
Thanks.
Yes, you can ask a question.
Yeah.
It's very interesting knowledge distillation solution. And my question is, since the small models learn some knowledge from the large model, but what I understand here is there's no way for the strategy of how is it input. Like the small model is just trying to learn the strategies there. But for the traditional fine-tuning way or continuous pre-training way, there are certain types of input. For example, if the United Airlines is trying to hire this model for their service solutions, but for the specific strategies, like in some certain conditions, this ticket could be refunded or not. But what if this situation is not included in the general ChatGPT model? Is there a way to input this policy into this?
Yeah, okay, let me rephrase your question. Your question, you're saying that if the strategy is not even known by GPT-4.
Yeah.
Yeah, if that's the case, then you cannot learn. You cannot do better than the teacher. If the teacher doesn't know, then you wouldn't get the instructions.
Okay,
So,
and
but I want to say that the flexibility of the method is that you can involve a human. If the human examine, okay, there's no such scenario, I can design the scenario and I can provide the guidelines, right? Basically, you can use human knowledge to augment this library, and then the problem is solved.
And in the library, in the prompt library, so there is a way that the model is trying to follow a specific strategy there. But I wonder if there is an upper bound or lower bound to regulate this method to make sure the model is behaved according to the policy without exceeding the upper.
What do you mean by upper bound?
Sometimes we give the distribution an upper bound to make this make the response very trustworthy. Like sometimes the AI security, the answer is not existing in the upper bound.
Can I come to your office? 15 minutes.
Although reliable. So if there's some mathematical way to define that this strategy in the library is very reliable and trustworthy.
If I understand it correctly, are you talking about the discrepancy between the student response, the student output, and the teacher output? You're saying that there could be some error, so
Yeah,
there's some bound.
Error.
Yeah, that's a good question. Mathematically, you cannot, because if we don't train the model, you don't get the output of the model, you cannot train it. But so what we are doing here, it's an iteration. So every time we will evaluate how good you are. So if the teacher believes there's improvement, we'll continue to do the training. And if the teacher believes, okay, this is good enough, then we'll stop. So I would say that it is solely determined by the GPT evaluator. If it's good enough, then it should be able to tell us whether there's improvement or not.
But there might be the problem that there might be a backdoor attack. For example, the student model may behave sometimes. Sometimes if the customer asks the model to get this ticket refunded, but in some error circumstances, the student model will just, okay, I'll refund. But that will cost some loss to the company.
I would think that if the student follows the prompts, then it should prioritize whatever in the instruction rather than following, agreeing to the customer.
Any other questions?
I just wanted to ask if you could go into a little more detail about how you, like, if you were to do this completely autonomously, how you would update the prompt in each step.
Oh, how I update the prompt. So right now we basically just append the prompt. Every time we come up with a new guidelines, we just append it to the prompt. So the prompt will grow. Yes, after long enough iteration, the prompt could be too long, then we ask the GPT to summarize it. But when we implement it, we find that we don't need to go many iterations. Usually under 5 iterations, the response is already good enough. So we don't deal with the issue of like very long prompt.
But what's the mechanism behind deciding what additional instructions to add?
What is the mechanism?
Yeah.
So we ask GPT to decide. So GPT comparing it and say, so because we said in the prompt of the evaluator saying that, okay, this is the lesser student's response, and you want to use it as a benchmark to create a suggestion to this guy in order for him to behave, to respond like the better LLM, and he will.
So if eventually the goal is to like let Llama 2 run on its own, right? Because you don't want to be, running GPT for every time something
Right.
is by.
Yeah.
Like how would Llama 2 by itself, or would you pair it with like some sentiment analysis sort of?
So are you talking about deployment?
Yeah.
In deployment, the Llama 2, every time you will see an input here, and Llama 2 will basically find the most relevant prompt and use the prompt, most relevant scenario and use that prompt.
For relevance, this would be like sentiment analysis, something or the other, to decide like what conversation sequences are most similar.
Yeah, you can look at the embedding of the scenario and find the closest.
Thank you.
I actually have a related question. Do you see because it's multiple conversation, right?
Mhm.
Do you see GPT may give a contradictory recommendation, like based on this two, they recommend do something, but then in the next dialogue, then you have something else, because it could be more precise, but the next one is be more detailed.
Right, exactly. Actually, yeah, that's a very good question. That is why we propose this scenario-based prompt. Because we actually, this is the result I didn't include. So we tried creating a long list of principles, like general guidelines, which is fixed. You have to follow that. But the problem is that when we implement it, in different scenario, the instruction is slightly different. Sometimes you want to be concise. You don't want to overload them, like at the very beginning. But sometimes when the customer specifically requests to know that you do want to provide more information. So that's why, the global prompt does not work. Global instruction does not work. Yeah. And in some circumstances, you apologizing make them feel better. But then if they're already very frustrated and ask you to do something and you're basically apologizing by, by getting away from them, by trying to apologize, then they'll get pissed. So there are different strategies. Sometimes they are conflicting. Yeah, that's a very good.
I thought finally you just have one global prompt to give at the beginning of the conversation, right?
No, this is the idea. So as the
Oh,
conversation
you have a
goes,
live-
as the conversation goes, every time you will encounter a new scenario, you will look up in the library, see what I can do. And then next time you look up again.
So then during the conversation, the agent is not just getting the question from clients, but also getting the prompt together.
Right, exactly. It's like every step, you were basically looking up in the library, what is the scenario, what I should do.
Oh,
Yeah.
Go ahead.
So you mentioned that at some point you might have to bring in a human into the process. And so I was wondering is like, how would you know when the optimal time is to bring in that human?
The human is not involved in the algorithm training. It is only involved in evaluation.
Okay, so there's no exit strategy. In other words, you're only going to engage the agent.
Yes.
You're never going to get to a human.
Yes, yeah. We don't.
GPT-4.
GPT-4 is acting as the customer because it has to be online learning. Yeah, but I understand the concern could be, yeah. But one possible way of incorporating the human would be like human interacting with the model to provide some feedbacks, and which could be used to modify the prompt.
I was wondering, if you go back to your bar graphs, assuming that there's statistically difference between, each of the implementations, at some point they may, level out.
Yeah.
Right, and so you might say, well, once you're at this level, it's time to, bring in,
Yes.
have an exit strategy or something. I don't know how to
Yes.
optimize that, how you.
Yes,
make it
it's
clear.
totally possible. Yes,
Yeah.
it's just the cost issue. We haven't been able to do that, but you certainly can. Yeah, because this algorithm certainly allows you to just replace the customer like GPT-4 with the human, then it will work. Yeah, we haven't been able to do that yet. Yeah.
Brian has one thing. Go ahead.
So just to make sure I understand, the library is all possible subsets of the conversation.
Yes.
And the size is n squared for the average length of the full conversation.
No, it's not. We are not doing like exhaustive search. We sample and the library, yes, it will grow until at some point. At some point, the teacher will say, okay, now you're good enough. We have a good enough coverage. Now you stop. Okay, so the library is not like gigantic. Yeah.
So there are some shorter subsets.
Yes.
And how do you know when it's good enough?
So okay, let me show you here. So here's iteration, right? There's some evaluator. So every time after one iteration, we decide. No, not we. GPT-4 will evaluate the performance of this student model with the current library to see if it's good enough. If
Okay.
there's no improvement in terms of rating, then we stop.
So it's a kind of convergence.
Yeah, it will
without
converge.
parameters.
Yeah, it will converge. Either you reach the maximum, like 5, or the GPT said after like several like n iterations, there's no improvement. It means that you basically reach your upper bound, then we stop.
Where the number of iterations is just some hyperparameter.
Yes, yeah.
May I know will the students also learn from the teacher's response or like they will only learn from the prompt?
So the student never gets to see the teacher's response. He will only learn from the prompt, where the prompt is generated by comparing student's response and teacher's response. So I would say that he is learning that in like not directly, but through the prompt.
Have we ever like compared the accuracy or like the outcome if like they only learn from like the teacher's response?
Are they fine tuning?
Yeah.
Good question. I didn't include it here. Yes, but we are better. We're better than the fine tuning. Yes, we also done this kind of evaluation, but the bar is low. Yeah.
Thank you.
Just curious to make the student or teacher more human. So, so this empathy, emotion, psychology aspect.
Mhm.
So how, well, I think, it's like getting to the social robot type of scenario.
Yes. Yeah.
So how you make this or potentially extend this to incorporate this kind of social interaction speech piece, like from pure text to almost like speech, right? I mean, you have to also take into account tone, volume of your voice. So
Yeah.
that kind of thing, I mean, is that something?
I think, yeah, so first of all, this method relies on that the teacher already being very good at the task. If the teacher cannot achieve that, it will not learn. And to incorporate that, the other aspects, I think one idea is that we could actually involve a human. And then at some certain, for example, we could let the student learn from teacher in the first few iterations. But when you're good enough to the point that even the teacher says, oh, I cannot help you, there's no improvement, then he plans to stop. At this point, we involve a human, even if it's costly, but then it's already at the last step, right? It may be worth spending the money. And then let the teacher interact, no, let the human teacher interact with the student and providing the feedback.
Along those lines, I would think it would depend, the GPT-4 would depend heavily on the prompts, which are involved in several places, right? There's evaluation, there's
Yes.
creating the list, there's knowing when to stop.
Yeah.
So that's another whole exploration space. Have you begun to explore that, and how did you come up with the prompts that you're using?
Yes, we actually, you're right. Sometimes it could be sensitive to the student and to the prompt. And actually for the same prompt, if you run it multiple times, you could get slightly different. But what we find that is that you could, on average, the performance is still consistent. It's just if the response itself could change a little bit, but on average, you'll get a consistent response. Yeah. Consistent evaluation scores. But yes, that's a source of variation in the output you could get.
Also see the GPT also get better with those refined prompts.
GPT-4 itself. Actually, there's a paper talking
So I
about
thought
how
it
you can
might
teach
be-
yourself.
Yeah, because you compare to those bad examples, then you summarize all those prompts, that could also help it.
That's true.
GPT
We
itself.
didn't try, but there's a paper already showing that if you like refine yourself, attack yourself, or refine yourself, there's improvement. Yeah.
Any other questions?
Uh,
Our lab president to
Yeah.
you first, then you, because you already asked, go ahead.
I mean, just following up on that thought, I mean, every time I make a phone call, somebody tells me it's being recorded. Did you go approach any airlines and get the recordings and use that as a gold standard, for lack of a better word?
Yeah, definitely.
And do that, and then, you can use that as the teacher.
If there's such data, but the other thing is, if we have that, right, that you will basically formulate the problem as like a supervised learning. It's like a one-step fitting. If you change the response, then the customer could say something else, then you don't have that in the data.
I mean, that's why I'm looking at, millions of people who have called, let's say, American Airlines or United or somebody like that.
Yeah,
Anyway, that's
we
fine.
could,
Got
we
it.
could, yeah, we could do that, yeah.
Go ahead.
Yeah.
That quick, can also check if anyone online has questions. Go ahead.
Considering that there are some human beings involved in the evaluation, and in fine tuning, there are some classical human preference optimization methods there, but nobody did that in prompt at this. So do you think that would be possible to build up a reinforcement learning from human feedbacks, just like what they do in fine tuning and make this portion here, make this framework more human interact?
Yeah, I think this is possible if we can directly get the output signal from the human. So for example, in some circumstances, if you see here, you see that even we have the teacher, but the teacher is not always better, like comparing this. Even this is a bad model, it's still selected 22 times over the other one. So if we have the human feedback, how we can use it is that every time we have the student and the teacher responds, right? And we don't take it for granted that the teacher is better. Instead, with let the human choose which one is better. So you are always learning from the best, the gold standard best, instead of just the teacher. Then it could further improve the performance.
When the teacher give you the feedback, ask the human if you like it. If human
Yeah.
doesn't like it, generate a new one.
Yes, yes, yeah.
Anyone from online?
Unfortunately, I joined a bit late, so I don't see anyone right now.
Did you see anything online? Just want to make sure we didn't miss it. I don't see anything in the chat, right? Yeah, then I no, I didn't see any in the chat box. So we're good. All right. No more questions. Thanks again for the time.
Yeah, sorry about food being late. There's a bit of a mix apparently.
Yeah, so basically. So right now you.
做的是这个出来
好呀
我们还可以再聊一下。
啊好呀
看我们做的东西可以给你讲。
好的，
晚上有空也可以好下去。
好呀。
现在快开始。